All right. So today we're looking at investment appraisal or capital budgeting. In simple terms, what this is telling us is how businesses choose which projects to invest. Okay, there are certain techniques that a business is going to use to see whether a project is profitable or if it's not profitable. All right. So there are various techniques that we're going to look at each one by one. The first technique that we're going to look at today is the net present value technique. Okay, this is the first appraisal technique, and it uses the concept of the time value of money. Madam, could you just mute your mic so that the others don't get feedback? Yes. So we're going to first look at the net present value technique. So the basis of this net present value technique is you're going to forecast cash flows in the future. You're going to estimate and say, if I get this project here, okay, if we invest in this project, you're going to estimate the money that you're going to make in the future. Okay. Now that money that you're going to make in the future, what you're going to do is you're going to convert it into today's value. Okay. You convert it into today's value. That is what is called discounting. Whenever you hear the word discounting, it just means converting money in the future into today's value. Then once you have converted that money in the future, converted it into today's value, you are going to compare it against the cost of the investment. And when you compare it against the cost of the investment, if your net present value is negative, it means you have to reject that project. The project is not worthwhile. If your net present value is positive, it means the investment is worthwhile and you can go for it. So let me illustrate what I mean. Okay. XYZ Limited is considering a project that requires an initial investment of 150,000. The project is expected to generate the following cash flows. So as I said, we are going to estimate the money that the project is going to be bringing you in the future. So this project, if XYZ Limited invests in it, in year one, they expect to make 50,000. In year two, they expect to make 60,000. In year three, they expect to make 70,000. In year four, they expect to make 80,000. So this money that they'll be receiving in the future, we have to convert it into today's value, and we're going to compare it against this cost of 150,000. So here, the company's cost of capital is 12%. Cost of capital, think of it just like as the cost of borrowing. Okay, to get this investment of 150,000, either the business has to go and get a loan from the bank or the business can sell shares. Okay, so now whenever you get a loan, there's that interest cost. That you can also think that of that as the cost of capital. Okay, whenever you sell shares, the shareholders are entitled to dividends. So that dividend rate is the cost of capital for the business. All right. So this cost of capital is what we're going to use as our discounting rate. This is the rate that's going to help us convert this money in the future into today's value. Okay. So the first one is calculate the net present value of the project and should the company invest. Okay, so let's do the net present value technique. Okay, sorry, colleagues, about that. Yeah, so we use the net present value technique. So if you remember from the time value money of money topic, I don't know if you, colleagues, did you do the time value of money topic? Did any of you do the time value of money topic? So you can close your screen. Okay, we never did the time value of money topic. This is how you convert money in the future into today's value. Okay, the present value equals the future value multiplied by 1 plus the rate to the power negative t. Okay, this is the formula we're going to be using to get our present value. So in this case, our R is going to be this cost of capital, which is 12%. All right. So you just make a table like this. Here you've got your years. Then here you have your cash flows. Then you're going to have your discount factor. And then you have your present value. All right. So the years, you're going to start from year zero. Year zero is the first day of year one. Okay. So in year zero, we are purchasing this investment. We are paying for this investment. All right. So we're going to represent it here as negative 150,000. Colleagues, why are we representing it as a negative number? Mm-hmm. Yes, because it's an outflow. It's money coming out of our pocket. Okay. Then in year one, we put our 50,000. Year two, 60,000. Year three, 70,000. Year four, 80,000. Okay. Then we go to our discount factor. All right. Remember, our rate is 12%. So 12% in decimal form is 0.12. So this rate, you add it with 1, 0.12 plus 1, you get 1.12. So each year, t, the value of t is the same as the year. So in year 0, the value of t is to the power negative 0. In year 1, the value of t is 1, so it will be 1.2 to the power negative 1. In year 2, 1.2 to the power negative 3. In year 3, 1.12 to the power negative 4. And in year 4, oh, so here 1, I forgot to put 2 here, it's a 2, then 3. So in year 4, 1.12 to the power negative 4. Now, you can tabulate these manually or you can use the tables, okay? Do we all know how to use the tables? Let me just get a table. These tables, you can get them on Google. Okay, let me just get one table here. And does your lecturer allow you to use these tables? Because if it says you have to use them manually, then you are doomed. You're not doomed per se, but it's better to use the tables. Okay, so on the present value table, you have your rates, all right, and you have the periods, okay. So let me see, let me download it so that I show us how to read this table. Okay, so the way you read these tables, you look for your rate. The rate here is 10%. Then after you get your rate, you look for the period, okay. So in year zero, since this 1.12 is to the power negative zero, anything to the power negative zero equals 1. Okay, colleagues? Anything to the power zero or negative zero is always going to equal to 1. So in year zero, your discount factor is always going to be 1. Year 2, year 1, your discount factor here under 10% is 0.909. Hope we're able to clearly see the figures. Okay, 0.909, this is the discount factor for year 1. Year 2, discount factor here, 0.826. Oh wait, I'm using 10%, not 12%. This table doesn't have 12%. Okay, we'll just have to do it manually then, because this table ends only on 10%. Let me see if I've got a table with 12%. Yes, here's a table where I can use 12%. So let me just get it there. Yes. So you look for a rate, it's here 12%. Year 1, our discount factor 0.893. Year 2, our discount factor 0.797. Year 3, our discount factor 0.712. Year 4, our discount factor 0.636. 0.636. Yes. Colleagues, any questions before I proceed further? No question? Okay. We can proceed. Yes. Once raise the hand, you can ask. You can go ahead with the question. Yes. 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 Mhm. It's just that in the exam, it's best you use the table. Okay. Because using the calculator might take some time. Okay. And in the exams, you're always going to be provided with the tables. Okay. And it's a must that you have to be given a table. So in case your calculator is not working that day, although when it's time to multiply, that's where you still need your calculator. All right. So colleagues, to get our present value, it's just this cash flow, the cash flows times the discount factors. So year 0, negative 150,000 times 1, negative 150,000. Year 1, 50,000 times 0.893. Let's get our calculators. What is 50,000 times 0.893? Four. Mm-hmm. Okay, for 4,650. So basically, this 50,000 which you receive in the first year, in today's value, it's 44,650. Okay, number two, 60,000 times 0.797. Mm-hmm. Okay, 47. Now, colleagues, you are going to be financial managers. Okay, so in the meetings, please read the numbers as they are. Okay, colleagues? You are financial managers, the directors of finance. Okay. Yes. The next one, 70,000 times 0.712. All right. Then year four, 80,000 times 80,000 times 0.636. All right. So, colleagues, we're now going to add up all these values to get our net present value. So, let's start. We'll say negative 150,000 plus 44,650 plus 47,820. So, you have already joined. You want to join with another gadget? It will have feedback. It will have feedback. Okay, okay. Because okay, let me okay, let me admit you. Okay, let me admit you with this one. Okay, then at least use one device so that we don't get feedback. Yes, Madam Chipi or Mr. Chipipa, your hand is still raised. Do you have a question? Okay, okay. Okay. Yes, so let us add. We add all these negative 150,000 plus 44,650 plus 47,820 plus 49,840 plus 50,880. What do we get? All right. Yes. So when you get a positive value, okay, the decision rule for net present value. If the net present value is positive, you accept. It represents gains from the project. Okay. So since the NPV is positive, we accept the project. Any questions? So this is how the net present value technique is done. You get your cash flows, multiply them by their discount factors, so you get the present values. Then you add all of them up so that you get your net present value. Any questions before we go to the next one? Internal rate of return. Okay, we go to the next technique, the internal rate of return, the IRR. Okay, so in the internal rate of return, basically, these cash flows, okay, it's going to give them to you in a percentage format. Okay, because remember, return is the money that you earn from a project or an investment, and return is usually given in a percentage form. So that's what the IRR is going to help us do. It's going to give us our return basically from this project in percentage format. Now, the official definition of the internal rate of return is the rate at which the net present value becomes zero. But a simple way of think of it to make life easy is just the return you're getting from your project. So the internal rate of return is just a continuation of the net present value technique. Only that this time you're going to need two net present values, okay? A positive one and a negative one, okay? So in the question they said calculate the internal rate of return using interpolation. Okay, so this is how we're going to do it. As I said, since it's a continuation of the net present value technique, so we just need to include in our table. Okay, we need a new discount factor. Okay, because since we've got a positive net present value, we want our next net present value to be negative. Okay, so this is one thing you should remember when you're doing the internal rate of return. Okay, if your first NPV is positive, increase your discount factor. Like in this case here, since our first net present value was positive, now we want to get a negative one. So in order to get a negative net present value, we need to increase our discount factor. Okay. So interpolation is more like a trial and error. You start trying discount factors higher than 12. Okay. You can try 13%, you try 14%. But in the exam, you don't have room to be trying trial and error. Okay. So one trick you can use is just multiply your discount factor by 2. Okay. Or if you don't want to multiply by 2, just get a higher discount factor, which you know that once you use that higher discount factor, you get a negative net present value. Okay. And then if your first NPV is negative, decrease your discount factor. Okay. So colleagues, here we have to increase our discount factor. So we can use 13%, but I think if we use 13%, we'll still get a positive value. So I think let's try to use 20%. Let's see if 20% will give us a negative net present value. Okay. If 20% fails, we'll try 24%. Okay. So our new discount factor is 20%. So 1 plus 20%. 20% in the decimal is 0.2. 0.2 plus 1, that's 1.2. Okay. To the power negative t. So in year 0, our discount factor will always be 1. So in year 0, it's 1.2 to the power negative 0. Then in year 1, 1.2 to the power negative 1. Year 2, 1.2 to the power negative 2. Year 3, 1.2 to the power negative 3. Year 4, 1.2 to the power negative 4. Okay, so we can use our tables. So I think here, did I get for 20%? Where's that table? Yes, we have 20% here on our table. Okay, so for year one, 0.833. Zero point 0.833. Year two, 0.694. Year three, 0.579. 0.579. Year four, 0.482. Okay, so we're multiplying our cash flows, these same cash flows, now with these new discounter factors. Okay, so in year zero, since this is one, so negative 150,000 times one, you get negative 150,000. That's year zero. Year one, 50,000 times 0.833. What do we get? Is anyone there? Yes. 50,000 times 0.833. 49,908. Wait. It should be lower because 0.833 is lower than 0.893. And not 41,650. I'm getting 40, 41,650. Colleagues, are we all getting 41,650? Okay. 60,000. 60. Okay, 41,640. Yes, I'm also getting that. 70,000 times 0.529. It's 7,000 30 kwacha. Then 80,000 times 0.482, you get 38,000. You get 38,560. Okay, let's see if this will give us a negative net present value. Negative 150,000. No, 150,000. 70,000 times 0.579. Or 40,000. 530. Okay. Okay. So this one, I think we need to increase the discount factor because we can already estimate 40, 40, 40. This is 120. 120 plus 30 is above 150. Okay. So we need to still increase our discount factor. Okay. Because we'll still get a positive net present value. So we need to increase our discount. So 20% is too low. So we need to increase our discount factor. So let's try then 30%. Okay, we try 30% because with 20%, we're going to get another positive net present value. Here we want a negative net present value. Okay, so we're changing our discount factor to 30%. As I said, for interpolation, it's trial and error. So if you see your discount factor is not giving you your results, you change it. Now, the only problem is 30% is not on the tables, so we'll need to tabulate these manually. Okay, so 30% is 0.3. 1 plus 0.3, 1.3. So we remove these ones and these values. So colleagues, let's use our calculators. 1.3 to the power negative 1, what do we get? 1.3 to the power negative 1. 0.769. Okay, 1.3 to the power negative 2. 1.3 to the power negative 3. And 1.3 to the power negative 4. 0.356. Okay. I think this one will get us a negative 1. Okay. So we start again. 50,000 times 0.769. What do we get? 38,450. Okay, 60,000 times 0.592. 35. Okay. Then 70,000 times 0.455. Or just mute your mics. Or continue. 31. 80,000 times 0.35. Um, 28,000. Uh-huh. Oh, flat. Okay. Yeah, here we'll get a negative one. So let's add negative 150,000 plus 38,450 plus 35,520 plus 31,850 plus 28,000. We get negative 16,108. Any questions before we move further? Okay, so now we need to put this in our formula. So just mute your mic. Just mute your mic. So from this table, there are just four figures that you need to collect. Okay, four figures. Okay. So first we need to get our L% is the lower discount rate. So the lower discount rate is this 12% we used originally. H% is the higher discount rate. So with the higher discount rate we use is 30%. NPVL% represents the net present value with the lower discount rate. So the net present value with the lower discount rate is this one, 43,190. We use the lower discount rate of 12%. And then NPV 8% is the net present value with the higher discount rate. This one which we got as negative 16,108. So the formula for the internal rate of return, the lower discount rate plus net present value with the lower discount rate divided by the net present value, the lower discount rate, minus the net present value with the higher discount rate, open brackets, the higher discount rate minus the lower discount rate. So this formula will be given to you in the exam too. Now, in different textbooks, sometimes they use A%, B%, I like to use this one's H and L. So our lower discount rate, 12%, plus our net present value with the lower discount rate, 43,190, divided by our net present value with the lower discount rate, again we put here, 43,190, minus the net present value with the higher discount rate, negative 16,108. Okay, then close the brackets. And here we have the higher discount rate, 30%, minus the lower discount rate, 12%. So you can keep them as percentages or you can convert them into decimals. But to make life easy, just keep them as percentages. Okay, so let's start our operation here. Let's start with this denominator. 43,190 minus, I'm starting with this subtraction here, minus negative 16,108. So basically here, this is the part I'm focusing on first. Let me highlight it. Yes. This negative and negative make positive. Okay. So 43,190 plus 16,180. What do we get? 59,370. Okay. Then 41,190 divided by 59,370. What do we get? Forty-nine, 43,190 divided by 59,370. What do we get? Zero point 0.728 multiplied by 30% minus 12%, that is 18%. So 0.728 times 18%, what do we get? We get 30, huh? Now just leave it as a whole number, 13.104. If you convert them to decimals, at the end again, you have to convert it back to a percentage. So you just leave it as a percentage, okay? Yes. So 12 plus 13, that is 25%, 25.104%. So this is how we make our decision, okay? Because basically what this is telling us is this is the return from our investment, 25%, okay? This is our return from this investment. So if your IRR is greater than the cost of capital, meaning your return is greater than the cost of borrowing for this project. Okay. If your return is greater than the cost of borrowing, then you accept. Okay. So, like in this case, our return, 25%, is greater than the cost of borrowing, which we incurred over 12%. So, we accept the project. But if your return is less than the cost of capital, meaning your return from your investment is less than the cost of borrowing for that investment, then it means you reject the project.